Hello, in this video we are going to solve this equation. The first one says 2 to the power of root x is equal to 8 to the power of x. To solve a question like this, we need to express this number. These are exponential equations. And to solve the exponential equation, you either make the bases to be the same or you make the powers to be the same. In this case, I'm going to make the bases to be the same, since I know that 8 can be written as 2 to the power of 3. That is 2 times 2, 4, 4 times 2, 8. So I'll have 2 to the power of square root of x is equal to 2 to the power of 3, then to the power of x. That is, if I apply the law of indices that say a to the power of m to the power of n is a to the power of m times n. If I apply it here, I will have 2 to the power of root s equal to 2 to the power of 3 times s is 3x. Now the bases are the same, so we can equate the powers. That means square root of x is equal to 3x. To get rid of this square root here, I need to take the squares on both sides. So if I take the square of this root s, I will have x equal to, then taking the square of this equal to 3x squared, which implies x is equal to 3 squared is 3 times 3, which is 9, and s squared is 3, s times s, which is s squared. Now if I divide both sides by x, x here will give me 1, x here, one of the x's will go, which means 1 is equal to 9x, which implies s is equal to 1 over 9. Okay, that is that for question 1. So x is equal to 1 over 9. And let's go on to question 2, which says log s squared minus 2 to base 2 is equal to log x minus 1 to base 2 plus 1. Let's do that here. Question 2, have log s squared minus 2 to base 2 equal to log x minus 1 to base 2 plus 1. Okay, so here we have log s squared minus 2 to base 2 equal to log s minus 1 to base 2. This one here is the same thing as log 2 to base 2, since all the logarithm here are to base 2. And we know that the logarithm of a number to its base is 1. The law says that log a to base a is 1. So since we have 1 here, to turn this 1 to logarithm in base 2, it will be log 2 to base 2. Since all the logarithm here, the ones given to us are to base 2. These 2 should be to base 2, which is log 2 to base 2. Now, if I apply the law of logarithm that says log p to base a plus log q to base a, which is log p times q to base a. If I apply it on the right hand side here, I will have log 2 multiplied by this. That is, I'm applying this law here. 2 multiplied by x minus 1 to base 2. Then on the left hand side, I have log s squared minus 2 to base 2. Since we have log 2 to base 2 on both sides, they can cancel out, so that s squared minus 2 is equal to 2 bracket s minus 1. So if I open up this bracket, I'll have s squared minus 2 equal to 2x, that is 2 times s, then minus 2 times 1, 2. And let's collect like terms, and that will give us s squared. When this plus 2x crosses to the other side, become minus 2x, then minus these 2 right here, and we have a minus 2 here rather. When it crosses the equality, become plus 2. Since I have moved everything away from here, so it should be equal to 0. And that will give us s squared minus 2x minus 2 plus 2 is 0. So this place is gone. Negative 2 plus 2 is 0. So our equation now becomes s squared minus 2s equal to 0. Since s is common here, we can factor it out. I have x into x minus 2 equal to 0. Therefore, s is equal to 0, or s minus 2 is equal to 0. Hence, s equal to 0 or 2 is the answer to that question. Then the last one, I have 4 to the power of x plus 1. Question 3. 1, 2, 3. 4 to the power of x plus 1 minus 9 times 2 to the power of x equal to negative 2. Equal to negative 2. Okay. Here, equation like this, we need to reduce it to quadratic equation before we can solve it. So this first, since I have 2 to the power of x here, I would like to make this first term here to arrive at 2 to the power of x, so I can substitute 2 to the power of x with something x. And this 4 can be written as 2 to the power of 2. Then multiply by this x plus 1. Or before I do that, let me apply the first law of indices here. If I do that, I'll have 4 to the power of x multiplied by 4 to the power of 1 minus 9 times 2 to the power of x equal to negative 2. So 4 to the power of x can be written as 2 to the power of 2x, since 4 is 2 to the power of 2. Then multiply by this 4 right here to the power of 1 minus 9 to the power, multiply by 2 to the power of x equal to negative 2. And this first term, I can write that as 2 to the power of x, then to the power of 2, multiply by this 4, and minus 9 times 2 to the power of x equal to negative 2. Since I have 2 to the power of x here, I also have it here, so I can replace it. So let p be 2 to the power of x, so that this equation becomes 2 to the power of 2 multiply, did I say 2 to the power of 2? I have replaced 2 with p. That will be having p to the power of 2. Sorry for that mistake. I have 2 to the power, p to the power rather, p to the power of 2 multiplied by this 4, then minus 9 to the multiplied by this p now, because we are replacing 2 to the power of s with p, minus 9p. This negative 2, I want to move it to the other side. So when it crosses equality, it becomes positive, equal to 0. And 4 times p squared is 4p squared. 4p squared minus 9p plus 2 equal to 0. we have arrived at a quadratic equation. So I will multiply the first term by the constant term. 4p squared multiplied by 2 is 8p squared. Now we'll look for two factors of 8p squared that can add up to this middle term, 9 and negative 9p squared. The factor that satisfies that will be factors of 8 will be 8p and 1p. Since 8 and 1 are factors of 8, the only one that we can add, the only two pairs that we can add to get 9 is 8 itself and 1. And now we are looking for negative 9p, so it has to be negative and negative here too. So that now we arrive at the factors. So I'm going to replace this middle term with the factors. So that I have 4p squared minus 8p minus p plus 2 equal to 0. I'm going to group it 2 by 2. I'll group this first together. 4p minus 8p, group it together, minus p minus 2 equal to 0. This plus changes to minus here because I introduced a bracket. So here, what is common? 4p can divide both, so 4p is common, we bring it up into p minus 2. Here, 1 is the common factor into p minus 2 equal to 0. We have a common factor p minus 2. So p minus 2, then we'll group this and this together. 4p minus 1 equal to 0. P minus 2, therefore, is equal to 0, or 4p minus 1 is equal to 0. Hence, p is equal to 2, or 4p is equal to 1. P is 2, or by divide both sides by 4 here, p will be 1 over 4. But we replace p is 2 to the power of x. So let's find the value of p from that. 2 to the power of x. That means when p is 2, it implies 2 to the power of s is 2 to the power of 1. Hence, s is 1. Again, when p is 1 over 4, it implies 2 to the power of x is 1 over 4. And I'm trying to find the value of x here, so I want to make this fraction here to have a base of 2. So I have 2 to the power of s equal to 1 over 2 to the power of 2, which implies 2 to the power of s is 2 to the power of negative 2. From the law of indices that says a to the power of negative n is 1 over a to the power of n. So 1 over 4 is of course 1 over 2 squared, and 2 squared can be written in negative indices as 2 to the power of negative 2, which implies x is equal to negative 2. And for s is 1 or negative 2. And that is all that I have for you in this video. I hope you found it useful. If you do, don't forget to like the video and also subscribe to the channel so you get notified when I release a new one. Thank you.